There is no new substance formed, hence I say it is a physical change, which is called as magnesium oxide. A precipitate is left over after the reaction. 2 to the copper as well as 2 to the oxygen. Hi, hello students, welcome to my YouTube channel Vidhyapeetha 9th and 10th, and I am Sandhya Srihari, come up with the chemistry first chapter of class 10 portion known as chemical reactions and equations. Alright, in chemistry this is one of the most important chapter. In chemistry, many students are facing difficulty in writing about balanced equation, writing about symbols, writing about valencies and various other things. So in my particular session, you will be understanding and knowing what is balancing, what are the different types of reaction, what are its importance, as well as you will be learning about all the concepts that is there in the NCERT textbook with respect to board exam. Can we start? Yes. So to start with, the name of the chapter, chemical reactions and equations. In this chapter, let us make our own content. So let us make our own content in which I'll be first of all allowing you to understand and making you understand about first thing called as what is a chemical reaction. First, what is a chemical reaction? This is the important thing what you have to know, what is a chemical reaction. Secondly, we'll be learning about what are physical changes and chemical changes. What are physical and chemical changes? We will also be learning them with the difference between them, as well as many examples will be given to you so that you will be able to understand it in a proper manner. Then we will be learning about the symbolic representations, symbolic representation of equations, as well as we will be learning about an important concept called as balanced chemical reaction. How do I balance a chemical reaction? That is the most important part of the chapter, where you have to understand about valency concept, where you have to understand about symbolic representation, the symbols which is going to allow us to analyze the reaction and its information, and we'll be learning more about it. Alright, so these are the 4 important contents that we'll be learning in this particular session. To start with, let us move on. Let us just revise a simple basic concept. The simplest basic concept is called as a physical change. Physical change you have been learning from class 6th, 7th and 8th, and according to me the best example for this is tearing of a paper. When I take a piece of paper and I am going to tear it, I can see that the main paper has been torn into simple, smaller pieces of paper. So what is happening here? I am easily able to make out that the physical behavior, the physical appearance of the paper, which was first of all a rectangle, has got down into simple crumbles of pieces of paper. I cannot see there is a change in the physical properties of the paper. If I look at the pieces of the paper also, I am able to recognize it is yes made up of paper. So I call it as a physical change. Trying to understand about the definition here, physical change, the type of change in which matter or substance acquire a new form, but there is no change in its chemical properties. So what is happening? I can easily make out. See, I have given the example of pieces of paper here also. If I have a full-fledged paper A4 sheet and it is torn, it looks like this. So I can easily make out a change in state of matter, and that is acquiring a new form, but there is no change in its chemical properties at all. Correct? There is no change in the chemical property. That means the paper is not giving rise to a new substance. That is the meaning of chemical change. What is a chemical change? A change in which new substances are formed, I call it as a chemical change. So, in physical change, the appearance of the substance can change or come to simplest format, but there is no chemical changes that can be seen. The best examples are tearing of paper, ice cubes. In ice cubes, if I take a bowl and keep ice cubes inside it, I can make out that these ice cubes are turning to water, right? But the simple form of the ice cube, the physical behavior of the ice cube is changing to liquid. The solid ice is changing to liquid. There is no new substance formed. Hence, I say it is a physical change. When we come to the third example, that is burning of candle. In burning of candle, normally we consider this example as both physical and chemical change. But when the physical appearance of the candle, which was a big, if I have taken this much big candle and I am burning it, I am able to see the physical wax on the outer surface is melting and just keep on dissolving. The size of the candle is reducing. So the physical appearance of the candle initially was this big, now it has turned to this small. Since the physical appearance is changing here, I call it as a physical change. So what are physical changes? The changes in which a state of matter is changing or converting it into new form, but there is no chemical change happening to it. I call it as a physical change. Moving on to the second part of the chapter, that is what is meant by a chemical change. We all know, we have been into kitchens, your moms, you also sometimes go to kitchen and do a number of heating work. You heat up coffee and give it to your parents. Sometimes you're grinding something. Sometimes it happens that you're just putting water and boiling it. So chemical changes are the type of change in which the matter or a substance undergo change in its physical as well as chemical property. And the most important thing is there is a completely new and different substance formed which can change the color, state and chemical physical property of a noticeable format. For example, I am taking a teapot and I am putting some water inside it. Then what do? We are just pouring 1 tablespoon of tea inside it, tea powder. What will happen if I am boiling this? I can make out that the transparent water after boiling and putting tea powder inside it is changing its color. The color of the water changes to reddish brown. And after I pour some amount of milk in it, the complete texture of the milk which was white has turned to brown, orangish brown. So we can say this is a chemical change in which the water is changing its color as well as chemical and physical properties also. There are some more examples given here. Burning of paper. The best example I always tell my students, whenever you have to understand physical change and chemical change, the best example what you have to keep in your mind is tearing of paper for a physical property or a physical change, and burning of paper is a chemical change. So when I burn a paper, I am able to see that the paper has changed its physical appearance also, as well as the paper has burnt black. This black ashes, I cannot regain it into different format or back to paper again. So a new substance called as a black ash is formed. Hence I say it is a chemical change. Our body is undergoing many changes. The respiration process is a chemical change. Digestion is a chemical change, and various other things like excretion, other metabolic activities are also certain chemical changes that are giving rise to new products. So we consider the third example as respiration, which is also a chemical change. So what are chemical changes? The changes in which the matter or the state of the substance is changing with respect to new substances, and the color, the state and chemical physical properties of those substances are also changing. These are called as chemical changes. Coming to what do I mean by the difference between. Now I got to know what is a physical change. Now I got to know what is a chemical change. But in book, if a question is asked to me, write the difference between physical and chemical changes, then what and all points I have to highlight on, so that my teacher is not giving or not able to deduct any marks, right? So we'll highlight on those points. The first column is giving me an analyzation of physical change. The second column is giving me an analyzation of chemical change. First point, physical changes are those changes when a substance undergo physical change, its composition remains the same. Okay, in this, the composition entirely changes and undergoes a physical change, composition changes entirely. Thus, a chemical change involves formation of new substance. In this, no new substance is formed. No new substance is formed. As I told you, when I tear a paper, the paper pieces are visible to me. There is no new substance formed. But burning of paper, ash is formed. So, physical change are those changes in which the composition remains the same. In this, composition changes entirely. New substance are formed. In this, no new substance is formed. Coming to second point, a physical change affects its physical property, that is shape and size. When I tear a paper, the shape of the paper is changing, the size of the paper is changing, correct? In a same way, when in chemical change, both physical and chemical properties of the substance are changing. So, in this, only physical property of the substance changes. In this, both physical and chemical property changes. Alright? Now, what are the best examples of physical change? First, I'll go for, whenever a difference between is asked, I will first focus on the definition. Second point, what are the things happening after the change is undergoing. Third, I'll give an example, so that my teacher will get to know that I am not writing the answer barely. I have the knowledge on the subject, alright? So, what are the examples? Freezing of water, melting of wax, boiling of water. Here I can make out that there is no new substances formed. Only the physical appearance of the substances are changing, therefore it's a physical change. Examples of chemical change are digestion of food, burning of coal, rusting. Very beautiful example. I told you respiration is also a form of chemical change. Same way digestion, because after I digest my food, there is a new substance formed, energy is released, ATPs are released. Same way, in burning of coal, the coal is turning to reddish brown and it is then turning, after the reduction or production of heat, the coal is turning to ashes. So, burning of coal is also a chemical change. Rusting, we normally know when iron articles are not painted and kept in moisturous condition or exposed to the atmosphere, it causes rusting. Therefore, digestion of food, burning of coal and rusting will be considered as a chemical change. Next, physical changes do not involve production of energy. As we all know, see, when I am tearing a paper, there is no production of energy. When water is getting freezed up to ice, there is no production of energy. Therefore, physical changes will not produce any energy. Whereas chemical changes usually produce energy. Because we have to heat the substance, I burn a paper. So the paper is lit up by the matchstick. There is a heat evolved there, and hence I say in chemical change, production of energy is important. Now, physical changes, no new substance is formed. We have just learnt it. In this, one or more new substances are formed. In this, no new substance. In this, one or more new substances are formed. Physical changes is easily reversible. This is easily reversible. I can freeze water to ice. I can melt ice. I'll get water again. That's a reversible process. Physical changes are almost reversible, whereas chemical changes are irreversible. Chemical changes normally are irreversible. There are certain reactions which can be reversed as well. So this is a part of the session in which you are being given with n number of points related to physical change and chemical change. In physical changes, I can see the physical behavior of the substance, whether it is changing its shape, size, or it is forming any new substance or not. In chemical change, we will be analyzing about the byproducts that are formed, as well as whether heat is released or not. Keeping in mind about the example that I have told, analyze chemical and physical change in a clear behavior. You also have it in your NCERT textbook. In the first page itself you have it. Just have a quick look at it so that it will be helping you out. Because NCERT is important for us to study and analyze it. Alright. So moving on to next slide. The next part of the session. I told you the next content is what is a chemical reaction. Right. We all know in and around our atmosphere, there are many types of chemicals. There are many types of reactions that are happening. Like if we go to a kitchen, the kitchen is a live example of our laboratory. Our moms, we, our sisters, many of the bachelors are daily doing many activities, many chemical reactions like boiling of water, like making tea, like cooking of rice and many other things, right? So in a chemical reaction, the analyzation, or if I have to just represent a chemical reaction in symbolic format, I have to just keep in mind about the symbols, about the nature of the substances and about the combination of the substances, whether the substance will react with each other or not, whether they exhibit heat or absorb heat. These are certain important things that I have to keep in mind before learning or writing about a chemical reaction. So first of all, to start with the chapter called as Chemical Reactions and Equations, let us try to understand what is a chemical reaction. It is the process in which substances undergo chemical change to form entirely new substance with entire new property. So it is undergoing a chemical change. For what reason? To form new substance which have new properties. Very simple, 3 words. It is undergoing chemical change. Why is it undergoing? Because it has to form new substance. Why new substances are formed? It has new properties, correct? So 3 things we have to keep in mind while defining a chemical reaction. First, undergoes a chemical change. Second, new substances are formed and new properties of those substances are exhibited. So here the nature and properties of product is different from that of the reactant. What do I mean by a reactant and a product? When we have a simple reaction called as H2 plus O2 gives me, when I have a simple reaction called as H2 plus O2 gives me 2H2O. 2H2 plus O2 gives me 2H2O. When we balance it, you will learn about balancing in further part of the session. So without just leaving a single second, sit exactly in front of your systems and watch the video perfectly. Alright. So a simple reaction is taken. Hydrogen is combining with oxygen to form water. In this, I am able to see that the state of hydrogen is a gas, the state of oxygen is also gaseous, whereas the new product formed is a liquid. So what is happening? When I have 2 substances reacting, I can basically get a new substance formed. The substances which are merging with each other, these are called as my reactant. And the new substances which are formed are always called my product. These two are separated in between by an arrow. Let me take one more example. Magnesium is combining with oxygen to form magnesium oxide. So when I have this, this is called my reactant and this will be called my product, separated in between with the help of an arrow. The simplest of the simplest reaction are also represented symbolically. The complex substances are also represented symbolically in a reaction. Therefore, I need to specifically know what is the symbolic representation of each element. So there are certain examples that we can take. Burning of magnesium ribbon. I told you magnesium react with oxygen to form magnesium oxide. Formation of water, H2 plus O2 gives me 2H2O. So these are the examples of a chemical reaction. Now, if I know what is meant by a chemical reaction, then there is a simple activity that is provided in my NCERT textbook. What is this activity analyzing? The activity is telling me about knowing what happens when we burn magnesium ribbon in air. What happens when we burn magnesium ribbon? What is a magnesium ribbon? It is a ribbon which is silver in color and it can be turned easily. Okay. Magnesium ribbon, basically, let us just understand with the help of the activity. In this activity, we need to take 2 centimeter long magnesium ribbon. We are taking 2 centimeter long magnesium ribbon and rubbing it over the sandpaper so that any dirt, dust is there, it is just going off. Then hold it with the help of a pair of tongs. Burn it using a spirit lamp or a burner and collect the ash so that ash formed in the watch glass, ash shown. So we'll go to the figure here. We have taken a burner and this is the tongs through which we are holding the magnesium ribbon here and burning it. When it is burnt, you can see some amounts of things are falling and they are collected in the watch glass. The things falling on the watch glass is nothing but magnesium oxide. The reaction type representation of this is 2Mg plus O2. Magnesium is burnt. I can only burn a substance when oxygen is there. So this is O2. Magnesium when burnt in the presence of oxygen is giving me 2MgO. Magnesium oxide. So magnesium is basically a silvery white metal which burns with sound, dazzling sound and flame, and a white color powder is collected in the china dish or watch glass, which is called as magnesium oxide. So what is happening here? In this reaction, two substances are combining with magnesium. The state of magnesium was solid, the state of oxygen was gas. When these two substances are burnt together or combining, we get a new compound called as magnesium oxide, which is solid in behavior. Therefore, 2Mg plus O2 gives me 2MgO is the simplest chemical reaction that can be easily experimentally known inside your textbook as well as inside your labs. All right. So, a chemical reaction in which substances combine and form new substance and the chemical behavior or the property of these substances are also new, I call such reactions as chemical reactions. Alright, this was exercise activity 1.1 in our NCERT textbook. Let us move on to the next activity that is available with us. Next, to understand about the reaction, we have just taken a reaction of lead nitrate with potassium iodide. What is lead nitrate? Lead nitrate has a symbolic representation of PbNO3 whole twice. This is lead nitrate. We are just making lead nitrate to react with potassium iodide, which is Ki. This is lead nitrate and this is potassium iodide. Let us just try to understand what happens when these two substances or the reactants are reacting with each other. So take lead nitrate solution in a test tube, add potassium iodide and just see the observation. This is test tube A in which lead nitrate is already taken, which is basically in liquid format, and this is test tube B in which potassium iodide solution is taken. So both are liquid or aqueous in behavior. I can say the state of the substance is aqueous. Correct? So when these two substances are combining with each other, we are not heating the substances, it is just mixed with one another. Therefore, after the reaction, I can see that there is a yellow precipitate of potassium, lead iodide that is formed. In this reaction, the lead is taking the position of potassium. So this is PBI plus KNO3 is left over. Therefore, the lead iodide here is the yellow color precipitate that is formed in the reaction or after the reaction. Why do we call it as precipitate? This is called as precipitate because after I mix potassium iodide to lead nitrate, I can see that this substance is not at all mixing up with the solution. This is the leftover residue format which is there and has a change in its color also. The solution of potassium iodide and lead nitrate, when mixed with each other, I can see a yellow substance that is left over in test tube A, which is called as lead iodide. Therefore, I can say that this is a type of chemical reaction in which a new substance is left over at the bottom. So we give it a name called as precipitation reaction. Precipitation reactions are those reactions in which a precipitate is left over after the reaction. We have to basically see this reaction given in 2-3 formats, and the activity can be represented as a case study question. What are case study questions? A simple diagram will be provided to you and 2 to 4 questions will be given to you. Based on the diagram and a paragraph, you have to answer the questions. So it's an important question or a case-based analyzed property in which what is going to happen to the reaction as well as balancing is to be learnt by my students. Moving on to the third activity. In the third activity, we have just taken some zinc granules and adding it to dilute sulfuric acid. Okay. In this activity, what are we doing? We have taken zinc granules. So zinc is represented with Zn and adding it with H2SO4. Sulfuric acid, H2SO4. It is one of the major acids present in the atmosphere with us. There are 3 important acids. One is nitric acid, sulfuric acid and hydrochloric acid, out of which we have taken sulfuric acid. So let us just check. So when I have taken a conical flask, this is a conical flask, and initially dilute sulfuric acid is there in the conical flask. To this we are adding zinc granules, and the conical flask is basically, we have put a cork to it and a glass tube is allotted with a cork. So when I perform this activity, I am able to see that zinc is added to sulfuric acid. The zinc is just replacing the hydrogen. So ZnSO4 and hydrogen gas is evolved in the reaction. We can see that some amount of gases are coming out after the reaction is happening, and that gas is allowed to pass through this tube, glass tube. The gas is allowed to pass through the glass tube. So how can I detect whether the gas coming out is hydrogen or not? I can easily detect this by pop sound. When the gas is coming out here, it will be giving a pop sound to me. That sound is making me to realize that yes, this is the hydrogen gas that is going to come out of the tube that is placed in the cork. So whenever some substances are reacting with each other, new substances are again formed. The new substances can be either a gas, either a liquid or a precipitate. I have to basically understand whether the substances formed are going to be gaseous state. When they are evolving, how will be the detection of the gases? Major gases that are evolved are hydrogen, chlorine, sulfur, sulfur dioxide, nitrogen dioxide, and oxygen, etc. We will be giving you some important things about the detection of various gases also. So in this reaction, when zinc is added up to sulfuric acid, zinc sulfate and hydrogen gas is evolved. The gas evolved can be identified by pop sound detection. In this also we have mentioned about the pop sound detection. So just pause the video for a while, read the points that is specified on the board so that you will be able to understand it in a better manner. Going to the fourth activity. The fourth activity, going to the conclusion part of the session. What did we learn? The above three activities help us in determining the chemical changes occurring during a chemical reaction. So when a reaction is happening, what are the changes that are going to happen? That is the first point. When a chemical change is happening, there are certain important things that we have to analyze. First, there can be change in state. I told you, when hydrogen is reacting with oxygen, I get water. So this was my gaseous state, this is also my gaseous state, but I get a liquid state. In the reactant, I have two gases combining and a product is left over with a liquid state. So I say the first property of a chemical reaction or characteristic of a chemical reaction is change in state. Second, there will be change in color. In the second activity, we analyze that when lead nitrate is reacting with potassium iodide, yellow color precipitate was formed. So that yellow color precipitate was lead iodide. So there can be change in color. The second characteristic of a chemical reaction is change in color. In the third activity, we learned that when zinc is reacted with sulfuric acid, H2SO4, zinc sulfate, ZnSO4, and hydrogen gas is evolved. The evolution of the gas is determined by an upward arrow like this. Since a gas is evolved, we say the third characteristic of a chemical reaction is evolution of gas. Fourth characteristic can be change in temperature. When we boil some water and put some amount of tea, there is a change in temperature for tea to be boiled. Therefore, we can say that change in temperature is also considered as a characteristic of chemical reaction. So, when we analyze chemical reactions, these are the four things through which we will consider or keep in mind and then go to the state of the substances, the products formed and its properties as well. In order to understand a chemical change, these 4 points are the most important and necessary points for us to memorize as well as to make a note. Please pause the video and just have a note of this or take a screenshot of the board so that it is going to help you out. Without hesitation, make a note of it, because this session is going to give you apt amount of information, clarity on the first chapter. Without even reading the chapter again, you are going to master in it. All right. So moving on, the next. So dear students, let us continue with the next slide. What is a chemical reaction? So till now we have been learning about what is a chemical change, correct? What is a chemical change, what is a physical change, and what are chemical reactions. Now we will be learning about what is a chemical equation. What are chemical equations? It is the symbolic representation, a very important definitions to be noted down. It's a symbolic representation of a chemical reaction in the form of chemical formula, sign, symbol, state, directions. So major things to be taken care of. We have to take care of the symbols that we write. We have to know about the state of the substances. We have to know about the sign conventions as well as the directions in which we have to write. For example, if a gas is evolved, I'll write an upward arrow like this. If a precipitate is formed, I'll write a downward arrow like this. So the direction in which the reaction is happening. If it's a reversible change, I'll write 2 arrows in this format. So how the changes are happening and how to represent it symbolically is called a chemical reaction. So in chemical reaction, there are two important things. The entities which are given in my LHS, this is my LHS will be called my reactant, and the entities which are given in my RHS will be called as my product. Okay. So if we take the example of magnesium combining with oxygen giving magnesium oxide, how will I write it symbolically? Magnesium Mg combining with oxygen gives magnesium oxide MgO. This equation is not balanced. I have to teach you all how to balance the chemical reaction. In the further part of the video, you will be learning about it. As of now, this gives me 2Mg and 2MgO. So first symbols are represented as I have highlighted here. Symbols I have written. The verbal expression is simplified to the symbolic format. The entities which are written in my left hand side, this is called the reactant, and the entities which are written in my right hand side, this is called the product. That means if two people or two elements are combining with each other, what are the new substances that are formed? They are called the product. So when I write symbols of the given reaction or the symbols of the element, the state of the element has to be expressed with it. Mg is a solid state, oxygen always gas, and 2MgO is again a solid state. So a simple just analyzing the knowledge on the type of matter, whether magnesium is having a solid state of matter, liquid state of matter or gaseous state, I can easily write the symbolic representation in a proper format. So here magnesium is combining with oxygen to give magnesium oxide is represented symbolically. This representation is called a chemical equation. When it is reacting, I call it as a chemical reaction, but writing it in a particular symbolic format is called a chemical equation. So when a chemical equation is given to us, I can basically say the characteristic. We have just now learned what are the four characteristic changes that are going to occur in the chemical change. So in a chemical change, many characteristics are going to In a chemical change, many characteristics we can analyze as well as reveal it in a chemical equation also. So writing a chemical equation is the task in the whole chapter where students are lacking. Many students are just writing O for oxygen, H for hydrogen, whereas you have to write O2. Why is O2 coming? Why is H2 coming? All those analyzation is important as well. So let us now learn to write a chemical reaction. A chemical reaction can be made more precise and useful if we use chemical formulas. Okay, first thing is we have to use chemical formulas. If I have to use chemical formula, I should know the symbols of the chemicals combining. So first I have to use chemical formulas instead of words. A chemical equations represent a chemical reaction. I told you. The things combining, reacting with each other is called a chemical reaction. Writing it in bookish way is called a chemical equation. Okay. So simple, we have taken the same example, magnesium combining with oxygen forms 2MgO. I have just shown you how it is happening. Magnesium symbol is Mg. It is combining with oxygen O2 to give magnesium oxide, that is MgO. If you look at the whole equation, I have written M in capital format, G in small, O is capital again, whereas magnesium oxide M is capital, O is capital. So whatever way I have written or the books are being published, you have to follow the same symbols. Like for aluminium, we will not write A capital, L capital. This is wrong. We'll write A capital, L small. Same with iron, Fe. This is the right symbol of iron. We'll not write it as F and capital E. This is wrong. So whenever symbols are written, look at the capital and small behavior of the symbol so that you will not go wrong in your answer sheets. So there is a specific way to write the arrows, write the state of the substance, and the numbers or the balanced formulas that are being used to write in front of it we'll be learning further again. To move on, after learning about chemical equations and chemical reactions, let us come to the main frame of the chapter called as balancing of chemical equations. What is balancing? It's as simple as we buy some fruits from the market. If I go to a market for buying fruits, I take 1 kg of apple. The shopkeeper just keeps 1 kg in one corner and the productive weight in the other corner, hence making the substance balanced with the mass of the substance. Any symbol or any element has its own mass, and the complete equation is relying on one component called as law of conservation of mass. What does law of conservation of mass say? Mass can neither be created nor be destroyed. The whole mass of the equation remains the same, right? So before combining whatever might be the mass of the substance, after combining also it has to be retained. Therefore, balancing of chemical equation is an important task which needs to be taken care when we are just writing a chemical equation. So first, if I want to learn about balancing of chemical equation, there are certain key points which we'll be highlighting on. What is the need to balance an equation? First, as I told you, the need is to make or satisfy the law of conservation of mass. First, I have to satisfy that the reactant side elements present with their weights are equal to the product side elements present with their weight, so that the law of conservation of mass is absolutely satisfied. So we have just given you what is law of conservation of mass. It states total number of atoms on the reactant side and that of the product side should always be equal. A word important, that is number of atoms. Total number of atoms present in the reactant should be equal to the number of atoms present in the product. That is highlighted in the second line. Pause the video, just take a screenshot so that you will be able to write it down in your book later on, or write it immediately. Mark it important because MCQs might be asked, why is balancing important? The answer is not law of conservation of energy, it is law of conservation of mass. So put a highlighter on this and further letting you know what are the importance of balancing in the next slide. How to balance a chemical equation? In this chapter, I told you balancing is the toughest part of the whole chapter. Many students will leave that. They'll think that anyway 3 marks it is going to come, ma'am, I'm not going to learn this. But that should not be our motto. We have to learn balancing. It is an important task. It will be carried forward further until you learn your chemistry stream. Okay. So what is or how to balance a chemical equation? First, I will be writing down the unbalanced chemical equation. The first step, we have given you the important steps to analyze or to balance a chemical equation. First, write the unbalanced chemical equation. Second step, count the number of atoms of each element on both reactant and product. Count the number of atoms in reactant and product side. So first write the equation, then count the number of atoms. Third, add coefficients to balance the mass of the equation. The coefficients must be whole numbers and one coefficient applied to all atoms of the molecule. This point you will understand while I do or take an example, not to worry about it. Repeat the step 2 or 3 times until the equation is balanced, and then you can see whether the atoms are balanced or not. In the reactant side and the product side, whether the count of the atoms are same or not, we will analyze. Let us take some examples and make you understand about how balancing is going to work. So, in this, first we are taking the example of the third activity, which is zinc added to sulfuric acid, H2SO4. This gave us ZnSO4 plus hydrogen gas was evolved. So first I am writing the raw equation that is coming to my mind when I am reading the statement. When zinc combines with sulfuric acid, zinc sulfate and hydrogen gas is evolved. I am writing the statement in a symbolic format. After I write the statement, I am going to check how many atoms are there in my reactant side and product side. So making a tabulation called as elements, reactants and products. Elements, reactants and products. What are the names of the elements that we have? We have zinc, we have hydrogen, sulfur, oxygen. 4 elements are there. Zinc, hydrogen, sulfur, oxygen. Same here. Zinc, hydrogen, sulfur, oxygen. Now we'll count how many atoms of zinc are there in the reactant. Zinc, in the reactant side I only have 1. In the product side I only have 1. So I'll write 1, 1 on both the sides. Second, hydrogen. I have 2 hydrogen in my reactant, 2 hydrogen in my product. Therefore writing 2 and 2. Sulfur, 1 in my reactant, 1 in my product, 1, 1. Oxygen, 4 in my reactant, 4 in my product. Now let us check which is not balanced. I can easily make out that zinc is 1, 1 balanced, hydrogen 2, 2 balanced, sulfur 1, 1 balanced, oxygen 4 and 4 balanced. Since the number of atoms on my reactant side is equal to the number of atoms in my product side, I say this equation or chemical equation is already balanced. If it is not balanced already, we have to basically multiply the number of atoms and write it, which we are going to learn in the next example. This is the equation in which the chemicals in the reactant side and product sides were already equated, equal to each other, and the mass is already satisfying. Therefore, no need to change any numbers of the compounds present here. Moving on to the next example. So taking the second example says balance the following chemical equation. In this example, we are being provided with copper combining with oxygen, giving us copper oxide. Many students don't know the symbolic representation. This represents copper, which is in solid state. This is oxygen, which is in gaseous state, and this is copper oxide, which is in solid state. Let us try to tabulate it. In my tabulation, I will add on elements, reactants, product. Let us just figure out what are the name of the elements here. I have copper, I have oxygen. Only 2 things are there, copper and oxygen. In my reactant side, copper 1. In my product side, copper 1. In my reactant side, oxygen is 2, copper is 1. So we can see that oxygen is not balanced. When oxygen is not balanced, I will check. This is 2, this is 1. So I'll multiply here with 2. This 2 has to be placed in front of the element like this. 2CuO. Students are just writing it as Cu2O, which is wrong. You cannot add a number in between the compound. You have to add it in front of the compound. So 2 is required for us to balance copper on reactant and product side. Hence this is added in front of the copper oxide. This 2 is creating an imbalance in oxygen here. 2 to the copper as well as 2 to the oxygen. So the oxygen which was 1 in my product side has now turned 2. So I have to balance the oxygen which is there in my reactant side as well. 2 oxygen is there in the product side. So I have to balance with the reactant side. Now I'll place 2 here. This 2 is basically changing the copper here. I will place a 2 here. So 2 copper, 2 and 2, reactant side 2 copper, product side 2 copper. Oxygen was already 2, we have balanced it as 2. So oxygen and copper both are equal, hence the law of conservation of mass is satisfying, the equation is balanced. After I balance the equation, I'll write the equation clearly. 2Cu plus O2 gives me 2CuO. This is the format of writing the equation again. We will not add on the numbers which are represented to use or used for balancing in the question itself. After I tabulate everything, at the end I need to conclude the answer, which is going to give me good rapport as well as good analyzation representation in the exam. Alright, moving on to the next question. This was a very basic question. Moving on with certain important questions. So we have just taken another example of balancing. In this, let us try to understand what are the elements that are combining. This is known as ferrous oxide, aluminium. This is aluminium oxide. This is iron. So what are the things combining in my reactant side? Ferrous oxide is combining with ferrous oxide is combining with aluminium to give aluminium oxide and iron. Now I have to balance this reaction or this chemical equation. As we all follow the same technique, this is my element side, this is reactant side, and this is my product. What do I have? The elements, can we name it? I have iron, Fe, oxygen and aluminium. I have three important elements present in my reactant and product. Iron is 2 in my reactant side and 1 is in my product side. Oxygen 3 in the reactant side, 3 in the product side. Aluminium 1 in the reactant side and 2 in the product side. So whenever a reaction is provided with any element with oxygen or hydrogen, I will first of all check whether oxygen is balanced or not. If oxygen is not balanced, I will strike to oxygen and then move on to the other. In this particular equation, I can make out oxygen is there in my reaction, but it is already balanced. See, oxygen is already balanced. 3 in my reactant, 3 in my product. Hence, I will strike to the other elements present which are not balanced. So, aluminium is not balanced in my reactant side. It is 1, product side 2. So, I'll make this 2 by multiplying it with 2. This 2 has to be placed in front of it. So, aluminium becomes 2Al. The same is happening with iron. Iron in reactant to product 1. I'll make this 2 by placing it in front of it. So 2, 2, 3, 3, 2, 2, all the elements present here are balanced. Hence we'll write the equation again. Fe2O3 plus 2Al is giving me Al2O3 plus 2Fe. This is the symbolic representation of this chemical equation with balanced format. Everybody are concentrating and just able to understand whatever things are done by us. I hope so. So we'll move on to the next question. Yes, let us take another example, the third example for balancing. This chemical equation is an equation in which, let us figure it out in a verbal format. What is aluminium? Al, aluminium is added with copper chloride to give aluminium chloride and copper. Sometimes in our NCERT textbook, the verbal representation of the equations are given and I have to write it symbolically. In this, symbols were given, I wrote it in the verbal format. Aluminium is Al, which is solid in behavior. CuCl2 is copper chloride, which is liquid in behavior. And aluminium chloride turns liquid and copper is a solid now. So what is happening? Let us just check how many elements are there and what are the counts of the elements in my reactant and product. So I have three major elements called as aluminium. The first element is aluminium, second is copper, third is chloride. Cl. I'll not write Cl2, Al2 like that. Only single count will take and then count the number of people present in the reactant and product. So aluminium in my reactant side I have 1, in my product side I also have 1. Copper 1 in the reactant, 1 in the product. So to see the equation, aluminium and copper are already balanced. Let us check for chlorine. Chlorine 2 in the reactant, 3 in the product. These two are not balanced. So I have to balance it. This is 2, this is 3 in my product. So I'll take a flip vice versa. I'll multiply this reactant side chlorine with 3 and place it in front of the compound, that is 3 here. So 3 into the subatomic number of chlorine is Cl2. So 3 2s are, chlorine is turning 6. This 3 is also changing the composition of copper. Copper is turning 3 now. Alright. So I have to make this 6. So I'll multiply 3 with 2. This 2 will be placed in front of the chlorine here. 2. So 2 3s are, now chlorine is turning 6 and aluminium which was single, this is turning to 2. Since previously aluminium and copper we thought it is balanced, but the change in the composition of the chlorine or its atom is changing the composition of the reactant side copper, product side aluminium. Now I need to balance both of them as well. So aluminium product side it is now 2. So I will check the product side here, reactant side here. I'll place a 2 or multiply a 2 with the aluminium present here. I'll place it here. So 2 aluminium, this is balanced. Now my copper is 3 here and copper is 1 here. I'll put a 3 in front of it. Now if we check, 2 aluminium, 3 copper, 6 chlorine, hence the equation is balanced. Let us write it once more. So it is 2Al plus 3CuCl2 giving me 2AlCl3 plus 3Cu. This is the balanced chemical equation of the given question when aluminium is combining with copper chloride and aluminium chloride and copper are formed. Initial stages you might feel that okay, 2 or 3 elements are already balanced, I'll just change one single component and make it equal to each other. But once we are adding one number in front of a compound, it is changing the composition of all the people or all the elements present in the whole compound. So just take a look at the type of things that we are doing on the board so that it will give you a basic idea on how to just cope up when the things are just changing on its own. So just make a note of it, it will help you out, and then moving on to next question. So my dear students, let us take another example in which sodium hydroxide is combining with sulfuric acid to give sodium sulfate and water. When these reactions are happening, I have to check whether it is balanced or not. The question is telling me to balance the chemical equation. Let us figure out what is the balancing component by writing down the name of the elements in the reactant side and product side, the count of reactants and products as well. The elements present with me is sodium, oxygen, hydrogen, sulfur. So in my reactant side, sodium is 1, sodium is 2 in the product side. Oxygen 1 plus 4 is 5. Here also 4 plus 1 is 5. Hydrogen 1 here and 2 here, therefore 3 hydrogen, but hydrogen in my product side is just 2. Sulfur, I have 1 sulfur in my reactant side and 1 sulfur in my product side. So as I told you in the previous example, if a reaction constitutes of oxygen and hydrogen with other elements, I will first strike on oxygen. In this equation, I have oxygen also, I have hydrogen also. But if I look at the composition of oxygen, oxygen is already balanced. Therefore, my next count will be on the hydrogen. I have to balance hydrogen first. Hydrogen, I can make out it is 3 here, 2 here, but in my reactant side it is present in two different compounds. One is NaOH, the other is H2SO4. So wherever hydrogen is present as even number, H2, 2 is an even number, I will not touch this compound. I will go to the compound where hydrogen is not even, and I'll try to make this hydrogen even. So hydrogen is 1 here, so the next even number will be 2. I'll multiply here with 2. Now what is the count of hydrogen? 2 into H is 2 hydrogen plus 2, hydrogen is changing 4. The 2 added on to the sodium hydroxide is changing the composition of all the elements. 2 with Na, sodium is turning 2. 2 with oxygen also, 2 oxygen plus 4 oxygen, oxygen is turning 6. An important thing to be noted on, whenever hydrogen is there in two different locations, I have splitted H and H2. H2 I am not touching because hydrogen is even. I will take H and make it next even. So the next even number is 2. I have multiplied the whole compound with 2. This 2 is changing the composition of sodium and oxygen, therefore writing down the changed compositions in my bracket. So now I can make out hydrogen became 4, whereas here it is just 2. So I'll multiply this with 2 and place it in front of the hydrogen here. So now this hydrogen is turning 4, oxygen, 2 oxygen here and 4 oxygen here, it is turning 6. Therefore, all the elements, if we check now, sodium 2 in my reactant, 2 product, hydrogen 6, 6. Oxygen 6, 6, hydrogen 4, 4, sulfur 1, 1. A simple trick of balancing an hydrogen in two different locations is being taught to you in this reaction. Pause the video, rewind it, re-watch it. If you have not understood, comment me below saying the same. So in this particular session, we have analyzed on balancing, what is a chemical reaction, what are the difference between physical changes, chemical changes, with further examples. So this is a session which includes the first chapter of class 10th, chemical reactions and equations, just taken about balancing the chemical reaction. We are going to come up with further more videos, interactive sessions in which you can interact with us, joining our community as well. So I am Sandhya Srihari and this is my YouTube channel Vidhyapeetha. Hope to see you in my next video as well.